Gold does not appear in rivers by accident. Every flake, grain, and nugget found in moving water represents the final stage of a geological journey that began deep inside the earth millions of years ago. Rivers are not creators of gold. They are natural sorting machines, quietly concentrating what geology has already prepared. Long before water ever touched these rocks, gold formed under extreme conditions. Heat, pressure, and chemically charged fluids moved through fractures in the Earth's crust, depositing gold inside hard host rocks such as quartz veins, altered volcanic material, and mineralized shear zones. These deposits remained locked in place until erosion began its slow, relentless work. Over vast stretches of time, mountains rose and fell. Rock fractured, weather broke down exposed surfaces. Gravity, temperature shifts, and chemical reactions weakened the host rocks surrounding gold-bearing zones. Eventually, pieces of these rocks detached and began moving downhill, guided by rainwater, gravity, and seasonal runoff. This is where rivers enter the story. As water collects into streams and streams evolve into rivers, they become transport systems. But unlike wind or ice, water sorts material with remarkable precision. It separates based on density, shape, and resistance to movement. Gold, being exceptionally dense, behaves very differently from ordinary rock fragments. When a gold-bearing rock breaks apart, the lighter minerals, feldspar, quartz grains, clay particles, are carried easily by flowing water. Gold resists movement. Even tiny flakes settle quickly when water velocity drops. This single physical property explains nearly everything about why gold concentrates where it does. Rivers constantly change speed. Narrow channels accelerate flow. Wide sections slow it down. Bends create zones of turbulence and calm. Obstacles such as bedrock ridges, large boulders, and natural cracks interrupt movement. Each change in energy creates a sorting event. Whenever water loses speed, the heaviest materials fall out first. Gold does not float downstream endlessly. It drops, settles, and locks into place whenever conditions allow. Over time, these settling points become concentration zones, places where gold accumulates not because of chance, but because physics demands it. This process repeats endlessly. Seasonal floods lift material and move it short distances. When waters recede, gold drops back into the same structural traps again and again. With each cycle, lighter materials are removed while gold remains. The result is gradual enrichment, a natural concentration process that requires no tools, no chemicals, and no human intervention. Certain river features consistently support this process. Where bedrock is exposed, gold can settle into cracks, fractures, and natural grooves. Once inside, it becomes extremely difficult for water to remove. These bedrock traps are among the most reliable gold-holding environments in river systems. Inside river bends also play a role. As water curves, centrifugal force pushes lighter material outward, while heavier material moves inward and downward. Gold tends to settle along the inside bend near the riverbed, especially where the current slows. Behind large rocks or natural barriers, pressure drops create calm zones. Gold slips out of suspension and collects in these pockets. Over time, these locations can hold surprisingly rich concentrations relative to their size. Even river sediments tell a story. Layers of compacted gravel beneath lighter sand often mark historical flood events. Gold commonly rests at the boundary between layers, where energy drops suddenly in the past. These layers are geological records of water behavior and gold movement. Importantly, rivers do not create gold-rich zones everywhere. Only rivers that intersect gold-bearing source rocks can concentrate gold. The presence of gold downstream always points upstream to a geological origin. a lode source that once released gold into the system. This is why understanding host geology matters. Gold-bearing rivers often drain areas containing quartz veins, mineralized shear zones, altered volcanic belts, or ancient metamorphic rock. These source regions supplied the gold long before the river began concentrating it. As gold travels downstream, it becomes more refined. Sharp edges smooth, irregular shapes flatten, nuggets become rounded, fine gold becomes flakes. This transformation does not reduce value, it reveals history. The shape of gold reflects distance traveled and energy endured. Another key factor is time. Rivers that have existed for long geological periods often hold more concentrated placer gold systems. Repeated erosion cycles allow gold to be released, sorted, reworked, and reconcentrated many times. Each cycle removes waste material while preserving the gold. This explains why some river systems continue producing gold generation after generation. It is not because gold replenishes quickly. It is because the river's geometry, geology, and energy profile continuously rework existing material into concentrated zones. Understanding this removes guesswork. Gold concentration follows rules. Density governs behavior. Water velocity determines placement. Bedrock structure controls retention. Source geology defines availability. These principles apply universally, whether in the Western United States, Canadian river systems, or historic gold regions worldwide. Professionals rely on these principles rather than chance. They observe water behavior. They study rock types upstream. They read sediment layers like pages in a book. They understand that gold rarely appears randomly. It appears predictably where physical conditions align. This is why experienced prospectors often ignore wide stretches of river and focus intensely on specific zones. They are not guessing. They are reading geological signals left behind by millions of years of natural sorting. Rivers are not treasure chests scattered with gold everywhere. They are conveyors, filters, and concentrators, moving material until physics forces gold to stop. Once gold stops moving, it tends to stay. This is the core principle behind natural river concentration. It requires no machinery to understand, no chemicals to explain, no speculation to justify. It is the direct result of Earth's physical laws acting consistently over time. When you understand this process, rivers no longer appear random. Each bend, drop, and obstruction becomes meaningful. Each sediment layer becomes a record of energy change. Each heavy material concentration hints at what the river has already sorted and preserved. Gold does not hide from those who understand how it moves. It simply waits where nature placed it. And once you learn how rivers naturally concentrate gold, you never look at flowing water the same way again. Silver often follows the same natural pathways as gold, but in quieter forms. Carried within host minerals, it settles where river energy drops, along bedrock cracks, compacted gravels, and heavy mineral layers. Understanding these natural concentration zones turns silver discovery from chance into geological certainty. There exists a class of stones most people step over without a second glance. Smooth, heavy, mysterious. Their surfaces whisper of pressure, erosion, and hidden histories sealed beneath layers of mineral armor. But beneath that calm exterior, these stones are not ordinary at all. They are geological vaults capable of concealing metals far more valuable than their dull exteriors suggest. Because inside certain river stones lie microscopic pathways, trapped mineral veins, and metallic residues that can reveal the presence of silver, and in rare cases, platinum. This truth begins far upstream, within the invisible conflict between bedrock and time. When the deeper layers of the earth fracture, when veins of precious metals erode grain by grain, the fragments do not disappear. They travel, pulled by gravity, swept by seasonal floods, tumbled by relentless currents. They break into smaller shapes and begin a journey toward the river. And once inside the water system, nature performs its slow and careful sorting. Dense minerals break away first. Metallic flecks seek the lowest crevices, platinum group elements. So heavy they sink almost instantly, find themselves trapped behind obstacles, between boulders and inside pockets of darker, denser river stones. To the trained eye, these stones reveal subtle clues: unusual weight for their size, metallic shimmer under angled light, a rough granular texture beneath a smooth exterior, or streaks of darker minerals trapped like threads. Some hold pockets of magnetite or ilmenite, minerals that often travel in the same deposits as silver and platinum group elements. Others hide thin microscopic veins, remnants of eroded ore bodies carried for ages through the water. The river transforms them, shaping the outer surface while leaving the inner secrets untouched. But the most overlooked indicator is density. When you pick up a stone and feel an unexpected heaviness, far greater than its appearance justifies, you're touching a geological accumulator, a natural container capable of housing precious metals in trace or concentrated form. Stones that appear unremarkable can mask brilliant mineral inclusions, tiny silver crystals embedded in quartz pockets, or platinum grains locked within dark, fine-grained matrices formed under immense pressure. Each stone is a product of millions of years of movement, collision, and natural enrichment. The true discovery lies in understanding that these stones do not advertise their value. They hide it. They disguise it under dull colors, ashy grays, iron blacks, muted browns. Yet when cracked open, some reveal mineralized interiors streaked with silvery flashes or darker metallic glints that resist corrosion. These aren't ordinary colors. They're signatures of metals that do not tarnish easily, metals that hold their glow even in the presence of moisture, metals that travel with the densest geological companions. Every river deposit is a silent archive of the Earth's deeper layers, and these stones are its encrypted chapters. For anyone who recognizes the signs, these stones present extraordinary scientific and financial value. Silver-bearing river stones, formed from eroded hydrothermal veins, are rich in conductive metals that have supported civilizations for millennia. Silver's atomic structure makes it indispensable for energy systems, electronics, medicine, and precision technology. It doesn't merely shine, it performs. Platinum-bearing stones, however, exist on a level of rarity that few elements can match. Platinum group metals are among the heaviest and least reactive substances on Earth. They remain unchanged in air, water, heat, and pressure. They are catalysts for advanced technology, essential components of high-end industrial systems, and materials of unmatched durability. Even in trace amounts, platinum elevates the value of any stone that contains it. A single concentrated pocket can outweigh dozens of ordinary finds, but the value extends beyond market price. These stones offer educational insight into geological ancestry. They reveal how mineral veins traveled, fractured, and redistributed over unimaginable timescales. They help mineral hunters, collectors, and researchers trace upstream patterns and understand the deeper architecture of Earth's crust. Each stone is a clue, part treasure, part scientific artifact, part historical record. The presence of gemstones and accessory minerals also enhances their worth. Some river stones containing heavy metals form alongside garnets, sapphires, chromite clusters, and polished quartz nodules. Others carry magnetic minerals that indicate ancient volcanic activity deep beneath the surface. This interplay of geology transforms a simple stone into a composite of rarity, beauty, and scientific meaning. Recognizing one of these stones can open opportunities. Collecting, refining, cataloging, studying, or simply appreciating the natural artistry of mineral deposition. The true value is not only in what they contain, but in the knowledge they offer to those who understand their silent language. Silver and platinum pricing fluctuates based on global demand, technological needs, and scarcity. Silver, with its high industrial consumption, holds a dynamic market value that responds to energy infrastructure, electronics, and medical sectors. River-derived silver, though often found in small concentrations, can accumulate to meaningful quantities when properly extracted and refined. Even small inclusions can command respectable worth depending on purity and concentration. Platinum is in a different category altogether. Its rarity and resistance to corrosion make it one of the most valuable metals traded. River-sourced platinum grains, though extremely rare, can be exceptionally pure. Because platinum group particles do not oxidize, even tiny grains maintain full weight value. A single stone containing visible platinum inclusions can exceed the price of multiple larger metallic finds. Additional minerals present in the same stones, garnet, magnetite, chromite, and quartz, can add secondary value if sorted and categorized correctly. Collectors, jewelers, geologists, and industrial buyers all play roles in determining the worth of these materials. Extraction, verification, and refinement require caution and knowledge, but the potential market return, especially when a stone reveals platinum, is significant. One overlooked rock could contain enough density and metallic purity to shift the perceived value of an entire riverbank. If you value geology-based discovery, natural gold science, and real-world mineral understanding, subscribe to ProGems. We focus on how Earth actually concentrates value through time, pressure, and natural law. Turn on notifications because the next river you study may already be telling you its story.